Hello chemists! Today we're going to talk about something really relevant as summer approaches, the chemistry of sunscreen. So what even is SPF? What does it stand for? Well, it stands for sun protection factor, and it measures specifically protection from UVB rays, and that's because for a while these were the only rays believed to cause damage. In some studies, printed SPFs on labels are much higher than the actual SPF, and so say you buy SPF 50. If you test it, it might on you actually be like SPF 15, and that's because SPF is not something that companies can individualize. So if you and your ginger friend put on sunscreen at the same time, they're going to need to reapply that sunscreen sooner to achieve the same level of protection from the sun. Okay, to calculate SPF, you're going to take how long it would take you to normally burn in the sun, so for me, and then you're going to multiply that by the SPF of the sunscreen you're using. 4. That number is going to be how long you're now safe in the sun. So that's 40 minutes. So how much SPF do you need? Well, take those numbers into account, obviously, but the FDA recommends going somewhere between 30 and 50, as there's no evidence anything over 50 is more beneficial, and that's because an SPF of 15 blocks out 93% of rays, and an SPF of 30 blocks out 97% of rays, but no SPF blocks out 100% of rays, and the benefits of going higher just decrease a little bit more each time you go up in SPF. So like SPF of 100 is still just going to be at like 98% of rays. You're not getting substantially higher. Sunscreens are actually tested by applying patches on the lower back, then using a UVB lamp until the skin around the patches is a pale pink, or the end point is achieved. The patches are examined and the time is accounted for. Okay, so example 1. If Erin can normally stay in the sun for 10.12 minutes before she starts developing a sunburn, and she applies SPF 100 sunblock, for how many minutes can she theoretically remain in the sun? And then for how many hours? So again, we're going to take how many minutes Erin can stay in the sun without developing a sunburn before she starts getting sunburn. And then we're going to multiply that by the SPF she's using. So that's 100. And then theoretically, she can stay out in the sun for 1,012 minutes now, which divides out to. So then UVA versus UVB. These wavelengths are slightly shorter than visible light, and there's also UVC with a wavelength of about 290 to 100 nanometers, but it's not a problem because it will be absorbed by ozone in the atmosphere before it can reach Earth's surface all day, every day. So UVA don't cause sunburn, which is why for a while UVB were the only rays believed to cause damage, because they do cause sunburn. But UVA is also known to increase your risk of developing skin cancer. Okay, so how do different types of sunscreen work? So physical sunscreen reflects back UV rays. So if your skin is right there, then the sunlight is going to go like that. But then chemical sunscreens work a little bit differently. So the sun is going to go into your skin. You're still going to get some rays, but it's going to convert those rays to non-damaging wavelengths of light or heat. So the biggest differences when choosing a sunscreen is they rinse off really easily and they leave kind of a white tint on you. Okay, so here you can see that zinc sunscreen leaves kind of like white freckles, like it goes on like a white powder. And also, it's not, even though this sunscreen says it's water resistant for 80 minutes, it's not. As soon as you put it on, you're protected from the sun. Chemical sunscreens penetrate the skin in a weird way that can later be measured in blood, breast milk, and urine samples. And they don't start working instantly, so you're normally going to have to wait 15 to 20 minutes before those start working. Chemical sunscreen is applied to Erin. So, as you can see, she doesn't gain the, like, ghostly white appearance from the sunscreen. So what's in sunscreen? Physical sunscreens have zinc oxide or titanium dioxide. This is what's known as sunblock because, as said before, it just kind of blocks out the UV rays. Both of these compounds are made of white powder, and it's kind of really similar to covering yourself in white paint. Instead of deflecting the UV rays, chemical sunscreens absorb radiation through their chemical bonds. As exposure to heat is prolonged, the sunscreen slowly breaks down and releases heat. Okay, so this is what each of these are. Higher SPF actually means higher risk of irritation, and that's because there are more of these active ingredients. And if you have sensitive skin, that can be a problem. Thanks for your